Welcome to session 6 of Unit 1 in learning the course Computer Organization and Architecture. In our previous session, we discussed about various data representations and how we are going to perform addition and subtraction on those representations. That is, we seen addition and subtraction on integer data, on floating point data, and also we seen addition and subtraction in BCD data. Now we are going to discuss, in this session we are going to discuss about the concept overflow. Okay. Now the main objectives of this session are to learn what is overflow and to learn how to detect overflow. The main outcomes of this session are, by listening this session, the student will be able to describe what is overflow and able to detect the overflow. Now, what is overflow? So, what is meant by overflow? First, we need to discuss what is the definition for overflow, how we are defining overflow. Two numbers of n digits, each are added and the sum occupies n plus 1 digits. That the n plus 1 digits cannot be accommodated in a register with a standard length of n bits, which is called as overflow. That is, here I have two 4-bit registers. Here I have two 4-bit registers. One register holds a value A, another register holds a value B. I want to do addition of A and B. I want to place the result into either A or into B. So here I want to add A and B. I want to move the result to either A or to B. If after adding A and B, if the result is having 5 bits, is it possible to place that 5-bit result in either A or in B, which are of having fixed size of 4 bits? Is it possible to place? No, it is not possible. We cannot accommodate 5 bits in a 4-bit register. This is to be called as overflow. So here, if you are adding two n-bit numbers, if the result is of n plus 1 bits, we cannot accommodate these n plus 1 bits in a n-bit register, which is called as a overflow. Now here, what we are doing for detecting the occurrence of overflow? So many computers detect the occurrence of an overflow by setting a corresponding flip-flop. In almost all the digital systems, we have a overflow flip-flop. So if that overflow flip-flop is set to 1, then we can detect that overflow is occurred. If it is 0, then we can say that no overflow. Okay. Now, how we can detect the occurrence of overflow? So, an overflow may occur if the two numbers added both are positive or both are negative. So, here one you have to remember. So, when overflow occurs, if two numbers are added, if both are positive or both are negative, in that case only you will get overflow. Okay. So, why? If two are having positive numbers, we are going to add those two numbers. If two are negative numbers, we are going to add those two numbers. If one is positive and other is negative, even though the operation is positive, we are going to do subtraction only. In case of subtraction, we will not get overflow. Why we will not get overflow in case of subtraction? If you do the subtraction, always the result is less than the largest of the given two numbers. That's why we will not get overflow in case of subtraction. So, why we will not get overflow in case of subtraction? If you subtract two numbers, always the result is less than the largest of given two numbers. So, that is, suppose for example, if I subtracted 15 minus 10, what I will get? I will get 5. This 5 always less than 15. I can accommodate 5 in place of 15. Suppose for example, if I subtracted 15 minus 5, what I will get? I will get 10. This result is always less than the largest. So, I can place the result in place of largest value. So, in case of subtraction, never overflow occurs. In case of addition only, we will get overflow. So, when two unsigned numbers are added, an overflow is detected from the end carry out of the MSB position, that is most significant position, that is out of sign bit position. By observing the end carry out of sign bit position, we will detect the occurrence of overflow. When two signed numbers are added, the MSB always represents the sign. The sign bit is treated as a part of the number and the end carry does not indicate an overflow. So, if you are adding unsigned numbers, so what the overflow, how we are going to detect the overflow? The overflow can be detected from the MSB position, that is most significant position. So, if in the most significant position, if you get 1, then an overflow is occurred. In the most significant position, if you get 0, will not get an overflow. But if two signed numbers are added, the most significant position is used to represent the sign only. In case of unsigned numbers, we are not representing sign. So, MSB always indicates the overflow. But in case of signed numbers, MSB is used for the representation of sign. So, that's why we cannot detect the overflow from the sign bit position. So, that is the value which is present in sign bit position cannot be used for the detection of overflow. Then, how we can detect overflow? So, here we need to observe the carry into the sign bit position and carry out of the sign bit position. Both the carries that you need to observe. If both the carries are not equal, then there is an occurrence of overflow. If both the carries are equal, that is the carry in sign bit position and carry out of sign bit position, both are 0, 0 or 1, 1, there is no overflow. There is no occurrence of overflow. So, if both the carries are sign bit position carry and out of sign bit position carry 0, 1 or 1, 0, in this case overflow occurs. So, that is if both the carries are different. In that case, we will get overflow. That is, here I given an example. If we add plus 70 and plus 80, plus 70 is represented as like this, plus 80 is represented as like this. If I add these two, I'll get the carries in sign bit position and out of sign bit position as the carry in sign bit position is 0, carry out of sign bit position, carry in sign bit position is 1, carry out of sign bit position is 0. Since both the carries are different, we can say that an overflow occurred here. That is, we cannot accommodate 150 either in place of 70 or in place of 80. We need an extra flip-flop for holding the entire result. Now here, if you observe this one, minus 70, minus 80, if I add these two, here I taken the 2's complementations of those numbers. If I add these two, I'll get the carries as the sign bit position carry is 0 and out of sign bit position carry is 1. Here both the carries are different. We'll get an overflow here. So, here how to detect overflow? If you observe the carry in sign bit position and carry in out of sign bit position. If both the carries are equal, that is both are 0, 0 or 1, 1, there is no overflow. If both are different, the carries are different, that is 0, 1 or 1, 0, there is a chance of occurrence of overflow. Okay. So, how we can get them? Exclusive OR. By, if I am passing those two carries to exclusive OR, if the exclusive OR gate returns 1, then we say that overflow occurred. If the exclusive OR gate returns 0, we say that overflow not occurred. Okay. So, I hope that you all understood how overflow occurs. What is overflow and how overflow occurred. Now, I am going to summarize the concepts what we explained in this session. In this session, we explained about what is overflow, and if I added two unsigned numbers, what overflow represents, how overflow can be indicated. If we added two signed numbers, how overflow can be represented, and how to detect overflow. So by observing the carry in sign bit position and carry in out of sign bit position, we can detect the overflow. So if we pass these two carries to exclusive OR gate, if the target returns a value 1, it indicates that overflow is occurred. So then we set the overflow flip-flop. So if the exclusive OR gate returns 0, we set the overflow flip-flop as 0. We make the overflow flip-flop as 0. That is, there is no occurrence of overflow. So this is about overflow. So to assess yourself here, I given a question. Please answer this question. The question is, define overflow. Explain how to detect overflow when adding two positive numbers with example. In preparing this presentation, I used the digital content from various public sources. It is used only for educational purpose and not for the commercial purposes.